What causes external interference in electrical engineering signal amplification circuits? Have you ever wondered why your audio or communication devices sometimes pick up unwanted noise? This issue often stems from external interference in signal amplification circuits. Let's break down what causes this interference and how it affects performance. External interference primarily comes from electromagnetic interference and radio frequency interference. These disturbances are caused by electromagnetic fields emitted by various external sources. When these fields interact with amplification circuits, they can introduce unwanted voltages or currents, distorting the intended signal. One major source of interference is electromagnetic fields from nearby equipment. Devices like motors, transformers, and power cables emit these fields. They can induce unwanted voltages in signal wiring through capacitive and inductive coupling. For instance, if insulation is not perfect, leakage currents can flow and inject noise into the amplifier input. Capacitive coupling is another mechanism at play. When two conductors are separated by a dielectric material, a changing voltage on one conductor can cause displacement currents in the other. This means that noise can easily transfer into sensitive amplifier inputs. To combat this, proper shielding and increasing the distance between conductors can help. Inductive coupling, or mutual inductance, is also a concern. When the magnetic flux from one circuit changes, it can induce an electromotive force in nearby circuits. This is particularly problematic for circuits with high current changes, like those in switching power supplies or motors. Common impedance coupling occurs when noisy and sensitive circuits share a return path. This can lead to voltage drops across the shared impedance, coupling noise into the signal path. High-frequency radio frequency interference can affect amplifiers, especially instrumentation amplifiers. These high-frequency signals can cause distortion, leading to DC offsets that may saturate the output. Crosstalk is another issue, where signals from adjacent circuits or cables couple into the amplifier input. This is common in tightly packed circuit boards or cables lacking proper shielding. Series mode interference can also introduce unwanted voltages in series with the signal. This can occur due to leakage currents or direct current conduction through thermocouples clamped to conductors. Filtering this type of interference can be challenging. To minimize these effects, several practical strategies can be employed. Using twisted pair wiring can help reduce magnetic pickup. Faraday shields, which are conductive grounded enclosures, can block capacitive coupling. Decoupling and bypass capacitors placed close to active devices can filter high-frequency noise effectively. Designing circuits with separate ground and power planes can also minimize common impedance noise. Differential signaling can improve noise immunity by amplifying the difference between two signals instead of a single-ended input. Additionally, series resistors and wave shaping can reduce high-frequency emissions. Lastly, using radio frequency shielding, such as conductive gaskets or copper tape, can protect sensitive circuits from external interference. In summary, external interference in electrical engineering signal amplification circuits arises from various sources, including electromagnetic fields, capacitive and inductive coupling, and common impedance paths. By implementing effective circuit design and shielding techniques, you can significantly reduce these unwanted effects and ensure accurate signal amplification.